Our next speaker, Dana Sherson, is a developer at Marketplacer. She studied graphic design and then accidentally became a developer, as you do. Dana likes to write, and this is not my words, this is Dana's words. I feel like I'm judging, but it's, yes, you said it. Dana likes to write bad fiction and take bad photographs. Dana also says it's obvious she's a terrible person because she's a Kiwi and she's no longer a vegetarian. But on the flip side, she's been writing Ruby for 11 years, so I think that clearly means she was actually a good person. And today Dana is going to talk about how to make our Ruby through 300 times faster. So let's welcome Dana.
Hi. So first of all, I'm a bit sorry for the clickbaity title, but once I thought of it, I kind of had to use it. This will be a story of how to make Ruby faster, but it will also be a story of linter design and the philosophy of spell checking and how many pink slides I can squeeze into one presentation. Turns out, if you're a bit slow to Twitter, you get the wrong Twitter name. But everywhere else, I'm Robot Dana, and I work for Marketplacer. And as everyone else is, we're also hiring. It's a great place to work. I've been there for 4 years or so, and I recommend it. So I wrote a spell checker. Why would I write a spell checker? Well, one day, I was fixing a typo-related bug, and typos are annoying. And if I can make a robot catch me from making annoying mistakes, that would be amazing. Because people correcting your spelling is also annoying, but if a robot does it, it's fine. So linters are awesome. I love RubyConf once you get it set up right. It's amazing. And I've looked at other linters. We had somebody talking about sync scores. Sounds like a great idea. And yeah, linters solve many problems. And how hard could it be? It's just, here's a list of words, and here's a way to read a file and pull out all the words in it. Straightforward. But you need your spell checker to not be more annoying than fixing bugs occasionally. Because if it's wrong, it's just really frustrating. So I need to be able to figure out that camel case is not a word, but camel and case are. And when they're uppercase and then it's just hard. It needs to be able to read through a huge list of files. Most spell checkers would only look at one file at once because you're only editing one file at once. But we know better. You have to edit 200 files at once or else you're not doing anything. It has to be able to cope with all the different kinds of characters you might end up putting in words because not everybody speaks English in 1980. And yeah, you need to be able to ignore URLs because even though URLs contain letters, they're not usually words. They're words mashed up together. And if you say every single URL is spelt wrong and then have to put them in a special file to say, no, this is fine, don't break the linter, that's frustrating. And so many other features that I just needed to be able to make the spell checker usable. But the most important feature was it had to be fast. Because if it's too slow, you're annoyed when you run it, you don't want to run it locally, you want to run it on build kite or whatever. And then you're just waiting, and eventually you have to fix one little typo before you can merge your fantastic new feature. So after writing a spell checker for a day, I had something that could spell check itself. And it could do it in 1 minute and 20 seconds, which is so fast, except it was only looking at 29 files. And we have 8,000 files in a Git repo. That would take hours. Eventually, I got it down to just being a few 100 milliseconds to spell check itself and a few seconds to spell check our entire, well, 6,000 files there. But that's after skipping generated files and VCR files and other things that nobody should be messing with anyway. So how do you write Ruby fast? How do you go from it takes a minute 20 to check its own 30 files to a few hundred milliseconds to check its own, or a few seconds to check 8,000 files or 6,000 files? Well, first, you write the code slow, because there's no point in writing something fast that does nothing. You've achieved nothing. I'm sorry. So I stumbled into this. I wrote this thing slow. I proved that it at least solved the problem. I could split up a file into words. I could compare it with a word list. And then I started refactoring. It's like, I know how to make this faster. I just do a bit of stuff over here, do a bit of stuff over here, and I broke it because I didn't have enough tests. I had some tests. I'm not a Philistine, but I didn't have enough. So I needed comprehensive tests. And then early on, I measure. See how long it takes, and then I can give a talk called 300 times faster Ruby. And then I improve a bit. And then I measure a bit more, see what I can change next, and then I improve that. And then I measure the next thing, and then I can improve that. And then I can measure and improve, and I measure and improve, and I measure and improve forever and ever. So you've probably heard this term before, premature optimization. It's a bit pejorative. Like, you know things. You've met code before. You know this thing is slightly faster than that thing. So you don't need to measure first. It's fine. We can call it pre-measure optimization. These are the things that you just know to do already. You've written an n+1 query before and decided you won't do that again. The next thing you want to do is profile your code. This will tell you which methods are being called, by what, how many times, what methods they are calling. And this is a great way to get insight into what to fix, what to improve. You'll probably be surprised. We use benchmarking tools to tell us, well, I thought this was going to be faster. I tried this and this and this, and it turns out I was completely wrong and the first way was fine. Or, this thing that I had to research 3 layers deep on search results in Google, it's like, this is what I should be doing. And last, there's a Unix tool time. It's quite useful. It will tell you honestly whether or not you made something faster or not. So here are 2 tools I recommend using for profiling Ruby. ruby-prof or prof. I'm not sure how to say it. Before giving this talk, I never had to say it out loud. And rbspy. ruby-prof is for when you're writing code that will run and then exit and give you a result. rbspy is for looking into processes that are running and watching what methods they're calling. So that would be good for a running Rails server, for example. Profiling will show you low-hanging fruit. It will show you where you need to look for the easiest things to fix up. It will help you find bottlenecks, the parts of your code that are slowing down the rest of your application. Perhaps you're asking the file system 2,000 times whether the file exists, but you only needed to ask it once. You might be calling out to a HTTP method 2 or 3 times. You might be only asking for like one little bit of data, but you get like all of your records from your database. And you'd probably be surprised at how many times things are being called. Sometimes profiling leads you off in the entirely wrong direction. We'll see that. So this is how I like to call ruby-prof. It's just a command line tool that you install with the gems. The graph printer I find easiest to read, and sorting by self means the time spent inside the method, but not the methods that method calls. Whereas sorting by total would be all of the time spent in that method and all of the time in the things the method calls. So here is an example of the output. As part of my spell checker gem, I had to write a git ignore parser. And this is the output of this being run against our main code base at Marketplacer, which has 8,000 tracked files. Now let's just zoom in a bit. And I'll make it pretty colors because this is easier to read and I can point to things easier. So you'll note that some of the lines have numbers. That's the line at the very left. That's the line that's being profiled at the time. And the lines above are the methods that are calling it. And the lines below are the methods that are being called by it. You'll see that the main thing this is doing, this match thing, it's doing 800,000 times because we have a 100-line gitignore file and 8,000 files. That's quite a few times to call the same method in a very short space of time. And you'll note that the fnmatch method doesn't actually call anything. That's because it's the end of the road. There's no more Ruby here. Everything else beyond is C. But I noticed something. I noticed this match method. It takes 17% of the time, 300 milliseconds of this profiled time. And it doesn't actually do anything. It just calls the fnmatch directly. So perhaps if I was to move this up to there, I would save some time. So here was the results before. Took 1.6 seconds or so. Here's the results after. Look, I saved some time. There's no more match method, and I saved that 300 milliseconds. But I didn't. Profiling will overinflate the amount of time that methods take versus anything else, because that's the thing that they track. They also don't track attr accessors, attr readers. So that made the change where I used the attr reader instead of the method call that I wrote up explicitly. It totally hid that new time. So time, this Unix tool, I ran it a few times. I couldn't see much difference between before and after the change. This is where I probably should have used benchmark. I've done this loop quite a few times now, and I still get excited and jump ahead sometimes. I think that's fair. You're like, a new thing, I can make it even faster. And no, you don't. So slowing down and trying things out, seeing the different ways that Ruby behaves. Benchmarks are great because you can write a little script and then share it to other people's computers and see if it's true generally, see if it's true in different Ruby versions, rather than just running it a few times and being like, oh, it looks better to me, I guess. So quit Slack when you're running a benchmark. It will mess with your results, and maybe your browser too if you want. If your whole benchmark will fit inside of RAM, you can turn off your garbage collection. Let's pretend I said that correctly. Garbage collection. And try and make it as boring and static as possible. Also, with a benchmark, it's a good idea to try different data, try what happens when it's nil versus empty, because you might find a faster way of solving a problem, but it only solves the most common case, and you've left all your edge cases just argument erroring in the wind. So benchmark itself is a part of Ruby's standard library, but there's a gem called benchmark IPS, which adds a bunch of features. And the IPS stands for iterations per second. So it gives you a nice average look at how things are, rather than being like, oh, it took me 20 seconds to boot up Ruby, 20 milliseconds to boot up Ruby, and everything takes 20 milliseconds, I guess. Oh, what did I do? Seriously? Come back. I thought I turned that off. So here's an example benchmark of different ways of finding the total of values in an array. There's array sum, which came in Ruby 2.4 and is slightly faster than everything else, it turns out. But I wanted to compare it to compare it to inject, compare it to stepping through each So you'll see at the top, I've got my range of different values. What happens if it's got 10 values in it? What happens if it's got 1,000 values in it? I should also see what happens when some of them are floats, what happens when it's an empty array. And then I confirm that the things that I'm comparing actually do the same thing. Then run GC one last time, then kill it forever, and then do a benchmark. And it turns out I've put the times in the corner there because I didn't want a whole nother slide. But yeah, if you're finding the sum or the total of elements in an array, just use sum. It's faster, somewhere between slightly faster and a lot faster, depending on your data. Here's the benchmark that I should have written when I was messing with those method calls. So I'm comparing how long it takes to access an IVAR versus an add reader versus a method with no arguments versus a method with an argument. And just for fun, I put keyword arguments in as well. And it turns out, this is the output of benchmark, that Ruby's pretty fast. But it also turns out that it is very slightly faster to use an add reader than it is to use a method with an argument. I zoomed in a bit so it's not quite so tiny. And I did some maths, and I saved 7 milliseconds, not 300 milliseconds, so this was an entire waste of time. But I learned something about how Ruby works. Also, don't use literal hashes in your keyword arguments because it's quite a lot slower. So that's how to measure code, and I also snuck in how to fix code as well, but it's fine. So there are 4 things, 5, 4, I don't know, I can't remember. How you make faster code? There's at least 4 things you can do. You can optimize the code, make it do the same thing, but better. You can parallelize the code, make it do the same thing in 2 different places at once, and then you reach done faster, hopefully. You can upgrade Ruby. Ruby core team are doing amazing things and making Ruby faster and faster and faster. If I run my same speller code on 2.4 versus or 2.3 versus on 2.7, which for some reason I made it work on all of them, don't worry about it. It's like a second faster, 2 seconds faster. I don't have to do anything except make sure things are up to date, which I should be doing anyway for security reasons. Or you can just delete features. Like, do you really need to be able to spell check and skip the URLs? Could you avoid doing that? I would save 2% of the time, but I thought it was worth the 2%, so I left it in. You could also just ask your boss for a faster computer. Like, that will make your code go faster. I promise. So there are a bunch of different ways to optimize your code. You can use a faster algorithm. You can get closer and closer to C. You could choose carefully the methods that you want to avoid ones with side effects or that you're not using or creating objects that you don't care about. And everybody's favorite thing, you can use caches. This project, Juanito Fatas, has a GitHub repo, which is just a document of different ways to optimize your Ruby code. It's quite well laid out, and I recommend it. But with all things, it's very specific to your one situation. There's not usually a use this always, it's always better. So faster algorithms, sometimes they're faster just because. Sometimes they're less careful. Like, they might not do a bunch of checks. They might carelessly assume that all of your data is correctly formatted. It means they can be faster, but maybe that's not everything you care about right now. They can be less flexible. You can kind of back yourself into a refactoring corner, stuck with this fast algorithm that doesn't let you add features that you need to. Sometimes, though, things are just better. That's nice. It's nice when that happens. You don't have to think about trade-offs. Here are some examples of ways to use faster algorithms. So when you're writing a spell checker, you have a word list. And you need to find out if your maybe word is in this word list. So you can either say, is aardvark a word? Is aardvark my word? Is apple my word? Is, I don't know, what's next? Abacus, let's pretend I know the alphabetical order. Anyway. And that will take a while. Speller's word list is 200,000 words long, which means that if I want to find out if, I don't know, zombie is a word, I have to go through 200,000 steps before I find out that, yes, you have chosen well. Or if it's not a word, I go 200,000 steps and find that I've made a mistake. Or I can use this bsearch method. This is on array. And what it will do is ask for the middle word in the whole list and say, is this my word or is it before or after? And then, is this my word or is it before or after? Then, and this my word is before or after. And it turns out you can go through 200,000 words in 20 steps, which is significantly faster than 200,000 steps. Even though you've asked for more information, rather than just, is this my word or not? Is this my word or is it less or more? Another example of a faster algorithm that is perhaps less flexible is date parse versus date ISO 8601. So date parse, you can give it any kind of a date. You can give it year, month, day, month, year, Tuesday. I thought I turned this off. Excuse me. Very disobedient computer. Right. No, it's fine. I'll just touch this a few times. Where date ISO 8601 is just strictly year, month, day. You don't get any choices. And this means that the computer has to think less about what you're doing. And it can just assume that your date is correctly formatted, which is fine if you're dealing with stuff from your database or a JSON API or something that you're confident is always going to be a particular format. So if you're using date parse, you're using more flexibility than you need. Another thing you have to do when you're writing a spell checker that asks for lots of files is talk to the file system occasionally. And you could use file directory to find out if this path is a directory or not, so I should look in the files. You can use file.readable to find out if a certain path can be accessed by has permission and and the file actually exists, and isn't just a soft link to nowhere. But every time you ask the file system for something, it takes a little bit of time. So we could use filestat instead, which gives us a bunch of information about a file all at once, and we don't have to ask the file system for anything again. Yeah. This seems like it would be going counter to what I said about don't do work you're not using, but sometimes the work you're not using comes along for the ride with work that you are doing, and it will make it faster to do it all at once rather than piece by piece by piece, but it's precisely what you needed. Why? Is it getting quicker? No, that's fine. Yeah, let's just move on. Another thing you can do to make your code faster is use narrow methods that do exactly what you want. See, I'm disagreeing with myself already. That's just sometimes one rule applies, sometimes another rule applies. So sum is a very narrow method. It just does one thing. Give me the total of these values. Whereas inject or reduce, which is its synonym, you can do anything with it. You can find the sum of an array, but it will do it slightly slower. When you're writing Rails, you've probably come across this method blank. It's everywhere. And it's written in Ruby, because Rails is written in Ruby. Some helpful person who I should have looked up to credit, but I'm sure they're very clever. And you can find out their name by going to Ruby gems and looking up the gem. But they wrote this gem called fast blank. And all it is string blank, which will tell you if a string is empty or has only white space in it. All it is string blank, but written in C. This turns out to be somewhere around 1 to 10% faster, depending on the contents of your string, and will make your Rails apps slightly faster without having to do anything but add a line to your gem file. Another fun example of this is using Ruby syntax rather than using methods. So, excuse me. What are you doing? Hope nothing important was there. Yeah, so have I really broken it? Are you good? So you can use, so in Ruby there's this exclamation mark method, which means not. But you can overwrite that. It's just a Ruby method. You really, 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 really shouldn't overwrite it, but you theoretically could. So Ruby has to ask if you've overwritten it every single time you try to not something. So if you replace exclamation mark with the keyword not, or instead of if this, you use unless, you will save a very infinitesimal amount of time. But if you're calling your method 1,000,000 times, it makes a difference. Another thing to do is avoid unused work. If I'm writing a spell checker, I'm probably going to end up writing a lot of regular expressions. I think I have about 50 or 20, or I don't know, there's a lot. And in Ruby 2.5, they added a method match with a question mark. And all this does is tell you if your regular expression matches that string or not. Where match without the question mark will give you match data, which will include where in the string the pattern was found, and how many captures it has, and where those captures are, and all kinds of fun information that you possibly don't care about. So if you don't care about that information for what your method is particularly doing, then you should definitely use match with a question mark. Another kind of unused work that you might end up doing is creating intermediate methods. Like if you need to look through an array backwards because of the way that Git's negation algorithm works, for example, you would need to use reverse each. You could do that by reverse.each. It will let you step through an array backwards. Or you could just use this reverse each method with the underscore. And that will step you through the array backwards in exactly the same way, but without creating this reversed array in the middle that it then has to garbage collect away. Is that mouse not going away? Never mind. Another kind of work that you might not need to do if you are just writing a Ruby script is using gems. I know we all love gems. They're great. But sometimes your script is short enough and you're just saying hello world Melbourne Ruby conference. And you don't need to import the Twilio API. I mean, you should, but just not when it's fine. And you can start Ruby with disabled gems, and you'll save 60 milliseconds, which doesn't look like much, but if your script only takes a few milliseconds on its own, you've saved some time. And I know type checking is everybody's favorite thing right now. We've got TypeScript and sorbet and whatever homegrown thing you're doing. And perhaps you're writing, raise argument error if you tried to call this with anything that wasn't an array with exactly this value. But if you're writing the code, all of the code that calls this method, have your tests do that for you. Have your tests say, this method is only called with an array with true and false in that order exactly, or whatever. I don't know. I'm not your parent. I don't care what you're. So, yeah. But if you have to do this type checking every time you call this method, then you're introducing slowness for no good reason, because you know what you're doing. You wrote your test. Your test passes. Your code calls the correct values. You're pretty sure. And then everybody's favorite moment, caching. Cache and validation is hard. You have to know roughly when you're going to stop using something and when something is going to change. But we're not going to worry about that, because that's somebody else's talk. We're just going to talk about how to memorize things and ignore like Redis or whatever. We don't care about them either. We're just trying to make Ruby fast. So you've probably seen this way of memorizing something. This is from my word list class in my spell checker. Just loads a file. Here's this list of words for me to check. If you're new to Ruby, that means or equals. If words is nil or false, then we do the slow thing. Otherwise, we return the fast thing, which is the last time we got all of 200,000 lines of this file and turned it into an array. And because it was nil or false, perhaps you wanted to keep track of whether it was false and not have to go back to the file system and find out if this file actually exists or not. So we can see if this instance variable that we've defined is there, and if it is, use it, and if it's not, do the slow thing. Maybe that's not enough for you. Maybe you have an argument to your memoized function. Then you can store it all in a hash. And hashes are pretty fast in Ruby. They've been worked on a lot. They're very well optimized. So in a spell checker, you're probably going to be come across the same word more than once, because people reuse words, especially in programming, where they'll say def, or if they're writing JavaScript in 2015, they write function. So we only need to look up each word once, and then keep track of whether or not it was in the word list or not. Here's our old friend B search you remember from earlier. So we can create a hash and use fetch, and then if we give it a block, that's what will happen if it didn't find the value it was looking for. And then in that block, we save to the hash we were just looking in the new value. So next time, it'll be there. Sometimes you need to unmemorize things, which is easy if you're just doing the or equals way. If you're doing the if defined way, you have to do all of this nonsense. And if you try and remove an instance variable that doesn't exist, Ruby will yell at you, so you have to check if it's defined. I mean, it really should yell at you, but it's annoying. It's annoying. Sometimes you really shouldn't do this. This is silly. But I wanted to be able to call this speller normalize method, which is Unicode normalize and lowercasing, and just turning it into a consistent string. I wanted to call this method on either token, which is a subclass of string and has a location, or just strings. And I wanted it to, it turned out Unicode normalize is a slow function. That's what turns like the specific character E with an acute and the E, and then the acute joiner character into the same character. Otherwise, they're not the same words. Anyway, turns out that's slow. So I wanted to keep track of the results of it. So this is how you memorize things on an instance method that will also apply to other things that equal it but aren't the same instance. Don't do this, it's silly. So that's how you do optimization. And I'm probably out of time for parallelization. No, I've still got time. Parallelization, doing things at the same time as other things. Just gem install parallel will get you 99% of the way there. But it won't make your code thread safe for you, unfortunately. Threads are in the same CPU. Processes are able to be run on different CPUs, but have a lot more overhead to starting them up. Thread safety, one of the talks earlier talked about keeping your code free of side effects. Essentially, that's what thread safety is. Data go in, data come out. Data don't touch anything inside, because otherwise you will end up with some situations where some data's been changed and some hasn't, and one process changed this thing and one process changed that thing. Yeah. Keeping it all in one line is much safer. Memoization counts as a side effect. You can probably get away with it, probably. But it does mean that if you add parallelization, you might end up writing slower code, because your memoization won't be working properly anymore. And you don't want to start 200 threads because you're iterating 200,000 threads because you're iterating through 200,000 things. Then the overhead of keeping track of all those threads will end up being slower than just doing things in order. You want to be able to, say, make 10 threads, and then when the first one becomes free, do the 11th thing, and the second one becomes free, do the 12th thing. Fortunately, Parallelgem handles pools for you, and it makes things so much easier. Returning data from threads is easy. You just end the thread, and then you have the data. And returning data from processes is really hard, because you have to write out the data that you want to return to the file system, and then return it, and then read it from the file system, and then, fortunately, that's another thing that Parallelgem does for you, because nobody wants to do that. Parallelization will generally make things slightly faster, depending on how many CPUs you have. If you have 8 CPUs, it'll be 6 times faster, because there's some overhead. So that's how you make Ruby 300 times faster. You write your slow code, you write your tests, you profile it to find out what you need to change, you benchmark to find out what you need to change it to, you optimize. Some of these changes will make improvements. Some of them you'll just get reset after half an hour of work, because it turns out that didn't actually do the thing that you wanted it to. Sometimes it's longer than half an hour of work. And then you realize that you should have benchmarked maybe a little bit smaller. And then you can parallelize. Having code run in different chunks makes it harder to profile. So I like to turn off the parallelization. Did I get it? Parallelization when running Profiler. Most of all, have fun. I find it fun. I might be a little bit broken. I find it fun doing this process of taking something and making it faster. But maybe that's just me. And if it really doesn't work, you can always just rewrite it in Rust. Thank you.